Hi guys, BuildZoid here, and today we're going to be doing a session summary for the 3060 Ti LN2 session that I did. Yeah, I was hoping to find a better word for that, but it's like saying session twice in a row just sounds weird in my opinion. But anyway, yeah, I ran the RTX 3060 Ti Gaming X that I have on liquid nitrogen, and the reasoning for why I ended up doing this is very, very simple. You see, this guy over here, called Extreme Funky, ran his 3060 Ti on dry ice. So previously, I think I had a 13880, which was at the top of the TimeSpy rankings, and then this guy came along and, beat me by about, like 120 points, or, yeah, so, like a little over 100 points, and I took offense to that. Now, the biggest problem with running the 3060 Ti on liquid nitrogen is the very awkwardly shaped mounting holes. So, basically, so there was sort of a combination of factors. One, I was like, well, somebody else ran their card on dry ice, so now I kind of feel obligated, like I should run my card on LN2. And the other issue is the mounting holes. You see, 3060 Ti's have rectangular mounting holes, which is incredibly annoying because also they're really far apart. That's the other thing. They're not like GTX 560 Ti mounting holes, which are also rectangular, but this is way longer. So the thing is, my actually, the only two LN2 pots I have for GPUs are the Derbauer Raptor 4, which is amazing, and I also have a Kingpin Cooling Tech 9 Fat, which not as amazing. Like, it works, but it's not as good as the Raptor is. But the issue with both of those is neither of them have like the mounting hardware to get all four holes on a 3060 Ti, but fiddling around a bit with the Raptor, I kind of came to the realization if I just kind of run it sideways, the widest hole spacing or the furthest out hole spacing on the Raptor would actually fit, which is what we're looking at here. So diagonally, this just barely works out. On the mounting hardware that the Raptor has. So I only get two mounting holes, which is not great. And also that LN2 pot is sideways, like is not straight. It is very much leaning to one side. So that's not great. It doesn't really affect the performance. It just makes it really awkward to get the GPU mounted because the LN2 pot is really heavy and you need to support it with something. And, now it's like going to put all of the pressure on like one edge of the LN2 pod instead of having a more even application of it. But anyway, and also the fact that you're using just two mounting holes means that if you, tighten down the screws a little bit too much, you're going to destroy the BGA very, very, very quickly. Because the PCB is going to put up a lot less resistance if you're just bending it at 2 points than if you're bending it at 4. So yeah, I was really, like, the realization of, like, okay, I can get the LN2 pod on there was, like, great. And then it was a matter of, like, we do still have to solve other issues, like the VRM cooling, because this card is a Gaming X, and therefore it only has a 7-phase VRM using 50 amp power stages, and quite frankly, you do not want to run 50 amps through 50 amp power stages. I've covered that in videos multiple times. You really don't want to do that. But luckily for me, I have a bunch of spare bits and pieces for the Ragentech Morpheus heatsinks, because I have 3 of them. They're really awesome. Like, I love those giant air coolers. And so I managed to do this right here, and this is actually spring-loaded. So yeah, I'm pretty pleased with myself on this mount, on this VRM heatsink mount, because yep, that is a Morpheus VRM heatsink. Just pop some M3 screws through the back of the card, put the heatsink on top of that. Then the heatsink normally comes with push pins, and the push pins don't actually line up. So that's why I had to. Well, the other thing is I despise push pins. Push pins are the worst mounting system I've ever come across. They are so bad. Like like every motherboard, like every piece of hardware I have that has push pins that I'm even remotely serious about using, I remove the push pins because they're terrible. Whoever came up with push pin, well, yeah, whoever came up with push pins, I hope you feel bad for coming up with push pins. But anyway, yeah, so got the VRM heatsink on there. There's a 2 millimeter thick thermal pad under that. And I didn't want to insulate the card, which was another thing that sort of limited the runtime for the session. Well, not sort of limited. That was the deciding factor for the runtime for the session, was just like I didn't want to run proper insulation because I want, like, the card is currently in my daily system. And the thing with insulating hardware for LN2 overclocking, like I like to use Plastidip. Some people use Vaseline. I think Vaseline is disgusting. And Plastidip is like if you apply it once and you do it right, you can leave it there forever. You literally never have to mess with your insulation again. You can keep running the same board for like years without ever having to like redo the insulation whatsoever. And so I really like that about Plastidip. But the problem is, and this is also a problem for any kind of conformal coating material, it does increase the thermal resistance of the PCB relative to the ambient air. In fact, even the solder mask itself actually increases reduces the thermal dissipation capabilities of the PCB. So if you see some like high power board designs out there will actually go out of their way to have the minimum amount of, well, just not have solder masks over the large power planes and ground planes and that kind of thing. And in fact, there's some GPUs that do that, some motherboards do that. It's not a very common thing these days, but on older hardware, it's actually not that rare to see like exposed power planes, exposed ground planes, just for the sake of getting more heat dissipation without actually having to rely on a proper heatsink, proper heatsink. So you just kind of, do that. And the thing is, so Plastidip obviously acts as a thermal insulator, and so does any other PCB coating, because it's not adding surface area, and it is another interface material between the PCB and the air, so thermal resistance goes up. And this PCB being not great in the power delivery department, I really don't want the VRM running any hotter than it has to, and also the same goes for the memory. Like, I just don't want the memory running any hotter than it has to. Now, a lot of people might be wondering about all of the modifications. We will be doing a separate video talking about all of the modifications. Maybe 2 separate videos, because I've kind of gone to town on the card. Anyway, the significant one, well, what you need to know about these mods is this is voltage control for the core, voltage control for the memory, and over here we have a hookup point for the oscilloscope, for the oscilloscope, so I can just plug in the oscilloscope into the card right behind the GPU core. So that I actually ran that plugged in on LN2, and that was awesome. Like, having the oscilloscope for voltage monitoring is just so freaking cool. Like, you can watch the GPU load, and yeah, anyway, so oscilloscopes are really good at being fancy voltmeters, which is kind of what they're meant to do. But anyway, other than that, we also have these hookup points for like basic just measurements for both memory and core voltage. Like, this one's not accurate. This one's really inaccurate. It reads pretty high. The power bridges help a little bit with making this a bit more accurate, but not really. Because it's so far away from the actual GPU core, and I don't think this PCB has that many layers. So, yeah, anyway, so that's sort of the significant mods. And so for, in terms of the GPU prep, it was basically just this, We've got the LN2 pot very much sideways. You can see how the card is not aligned with the edge of the LN2 pot at all, right? Like, well, it's the LN2 pot's not aligned with the camera either, but yeah, so you can see how the LN2 pot's leaning to one side. Then we have the VRM heatsink. I kept the sort of PCB brace up along the top edge of the card because it cleared the LN2 pot, which I didn't originally think it would, but it did. So that's really convenient because it just means the PCB's less bendy. And we put hopefully that makes the whole thing less, more stable in terms of just setting it up. So I guess let's take a look at what it looked like in the actual system. So here it is in the system, minimal insulation. As I mentioned, I didn't want to run Plastidip because I'm dailying the card. I'm literally dailying the card. Here it is. It is currently it is, currently being used. The thing is, I have OBS set to record like CPU encoding, so it's not like the GPU is actually doing any work, but it is in the same system, and I guess it's handling the display output. So yes, I am using the 3060 Ti right now for actually recording the video, and that's with all of the modifications still in place. Like, I don't see a reason to take them off. I have faith in them lasting at least a year or two, hopefully more than that. But... And I have run modified cards in the past in my daily system for extended periods of time, but never this heavy. This card is like, I went to town on this thing. Anyway, so here's the setup. We got a fan for cooling down the VRM because I don't know how much power the card would end up pulling on liquid nitrogen. And the last thing I want is the VRM exploding. Yeah. So that's what's going on with that. And then in terms of insulation, we've just got blue shop towel rammed in around the LN2 pot. My plan wasn't to take it super cold. Like, I wasn't going to be going as low as possible. My plan was to just take it down to like -80 or something, like a relatively warm temperature, so that I don't have to deal with ridiculous amounts of condensation. Because if you go much below like -80, you start ending up with like the PCIe slot turns into like freezes up, and then you have to prep the board. You have to prep so much more if you want to go really, really cold. And also it would just mean that this level of insulation would be totally unacceptable. Between benchmark runs, like the PCB in this area would be getting pretty close to room temperature. And so, yeah, if I actually took it all the way down, I'm sure even with the VRM heatsink, well, even like it would just end up turning the VRM heatsink into a block of ice, which would then turn into a puddle when the card goes under load. And so, yeah. Anyway, just a towel to support the LN2 pod in place. Initially, I was considering running the card on a riser, but I don't have any PCIe 4.0 risers, and you get I thought about it, and I was like, you know what's more concerning than resting the weight of the LN2 pod on 2 mounting points? Having the whole card fall off of whatever thing it's sitting on, right? Because one of my ideas to sort of minimize the stress on the card was, like, instead of having the weight of the LN2 pod supported by the card, I'd have the LN2 pod sitting on a box or something, but I don't really have a way to, like, mount the LN2 pod to whatever it would be sitting on top of. And so I just kind of went with this setup right here where, it's padded so that the card really isn't like, I have so much padding here with that towel that it's not leaning back. It's not leaning towards us, right? Like the weight of the LN2 pod is in front of the card, so it's not leaning forward. It's actually slightly leaning back. And so I felt like safe with that kind of setup where it was like, okay, this should be fine. It shouldn't break the PCB. Because, yeah, the thing is, those LN2, like, that pot, I think, is approaching 2 kilograms, and so pretty easy to break a card with it, potentially. Like, if you mount it wrong and just, yeah. So this is a bad idea. And then for the back of the card, so at the start of the session, I just had nothing, because initially I was just pre-testing to see, make sure that the 3D Mark Time Spy is running correctly, make sure that like everything's working correctly. And the first issue I ran into with doing the pre-testing is that with the with the shop towels on top above the memory chips would get so hot so quickly that, like, right now this card is running 1339 and it dailies that. I've played games with that. Like, it's great. Honestly, this isn't maxed out. I literally just slapped it to like 1330. Because the thing is, when I was benching the card with the current voltage settings that are on there, because the memory volt mod is still active, because that one's worth to keep turned on. The core voltage mod is completely useless at ambient, or, well, basically useless at ambient. It's not completely useless, but the performance gains it offers are so marginal that not worth it. Because you lose idle and everything, and it's not worth it. So memory voltage mod is still turned on, And yeah, I can daily like 1339 with that. When I was benching with these voltage settings, it'll bench like 1450 potentially on the memory clock offset. But when I was pre-testing with the shop towels, between the LN2 pot and the memory chips, with the LN2 pot at like 20 degrees Celsius, the memory gets so hot that it couldn't really run more than like plus 1,000. So that was sort of the first issue I ran into with the session, was just like the memory overclocking went straight to hell because the memory chips were getting way too hot before the benchmark even finished. And so ultimately, like the original plan was like, hey, I want to pre-test everything, so then I just have to cool down and bring the core clock up. But you can't do, like, I couldn't do that because I couldn't pre-test the memory with ambient because yeah. So I ended up with pretty low memory clocks compared to some of my previous runs on this card. Actually, let's pull up. Actually, like, this is lower than what I'm currently running right now, like the 2058. Like, I think right now I'm at like 2080 something. Where's GPU-Z? I don't have GPU-Z. I hate how, like, NVIDIA cards have this completely insane clock speed readout. Like, as far as I know, that's not even accurate. Like, it's not actually running. So GDDR6 is weird because there's actually, like, two clock levels. You have, like, a base clock, and then, like, you have a command clock, and I think you have a data clock, and the data clock is, like, twice the command clock. And anyway, so GDDR memory systems are whack. In terms of how they're clocked. But yeah, anyway, let's pull up some of the history for this card. So, nope, video cards. If you're looking at that, like, you have a lot of cards now, there's a lot of duplicates in here. At the same time, there's a lot of cards not in this list. So, yeah. Anyway, where is that 3060 Ti? Oh, no, we're way too far down. There it is. Oh yeah, see, like that's the thing. Like I said, there's duplicates. Oh, come on. So that would be the old top score for it, right? Yeah, 1388. And you can see how I was running like 2091. And I don't think that was even maxed out. I think the card can do like 2100, but not, not like, it's not a balanced run when I go for max memory. So yeah, anyway, so on the LN2, the memory was very upset when I had it ambient. Oh, also here you can see the coax connected to the back of the card for the oscilloscope, and you can't yet see the memory voltage monitoring. So I didn't really want to spend too much time on this because obviously the card doesn't have any insulation, so it was supposed to be a very quick session. And so while I did hook up the voltage readout for the memory, I didn't actually mess with the memory voltage whatsoever. Anyway, let's move on to the next picture. Yeah, so here you can see the memory voltage readout, LN2 pot at 27 degrees. There we have the voltage level on the oscilloscope, and of course the horrible mess that is my desk. VRM cooling again, along with, I guess, the V-core switches. I just have a bunch of pictures that I took from the session. Okay, and this is how I ended up deciding to handle the back of the card. So basically, there's sort of two approaches to handling insulation for sub-zero overclocking. One, you can just prevent condensation from shorting stuff out, right? That would be like your Vaseline, your Plastidip, your Conformal coat, your, whatever you coat the PCB in to make sure that the water can't get to the PCB. That sort of, so that's one approach, is you just waterproof the hardware to the best of your ability. Now, the other thing you can do is you can just make it really, really hard for condensation to form in the first place. See, condensation requires humid air to form. So if you just minimize the amount of airflow available to cold parts of the card, like, say, the back of the card and the area around the LN2 pot, you can minimize how much condensation there is. And do I have a good picture of that? Hopefully I do. Yes, I do. I have a decent picture showing how that looks in action. So basically my idea was so I have a bunch of these standoffs, like, yeah, like, basically I've discovered that I really, like, these are super handy. You need to put a motherboard upside down, stack some standoffs, bam, motherboard goes upside down. You need to stand a motherboard on its edge, stack standoffs. So I just have a ton of standoffs because they're super useful for just getting motherboards in awkward orientations. But they're also helpful when you need to, like, I use them for locating fans above memory and that kind of thing. And, you know, here I realized, wait a minute, if I just put the standoffs here, I can just jam the towels between the standoffs and the card, and they'll just kind of stay, you know, pressed up against, like, they'll really reduce how much airflow gets to the, or more like fresh air. It is airflow. Like, it's not a lot of airflow, but it is still technically airflow. So, like, I won't have air, you know, like, washing over the back of the PCB if we have all this towel in the way, because there's freaking towel in the way. So that'll really minimize the condensation buildup on the back of the card. I do have a photo from the very end of the session where, you know, like, I turned the system off and then I just pulled all the towels off, and there was very little ice buildup behind the card, even though it was well below zero. Yeah, anyway, also, you know, wherever, like, the towel can also help with just absorbing liquid water if it gets in contact with it. It's not super, like, in this configuration, it's not going to do a great job of that. You'd really want to press it into the PCB a bit better than this, but you know, for a short session like I was doing, this was totally acceptable as far as I'm concerned. So yeah, here's just another picture of the setup. I'm running a Gigabyte B550 Vision D-P. I really like this board. It's very good. It has all of the benefits of a B550 chipset with none of the downside of the B550 Aorus Master. Namely the dual BIOS on that board. The dual BIOS on that board is so frustrating. Also, the latest BIOS for this motherboard sucks, by the way. For memory overclocking, the newest BIOS for this board is trash. It is so bad. I don't know what AMD did to the AGSA, but they broke it. Like, so I'm actually on, like, an older AGSA version on the board right now, because the latest AGSA, the memory overclock, like, they shaved off like 200 megabits per second of clock speed. And I don't, like, how do you do that? Like, how do you break your memory training that much in one update? Anyway, so yeah, it's from the start of the session, and now we get to the, you know, cooling it down a bit. And since I wasn't going to full pot, I didn't see a reason to, like, properly insulate the LN2 pot. Normally, if I was going to lower temperatures, or if I was running a longer session, I would actually wrap the wrap towels around the LN2 pot so that it doesn't end up completely covered up in ice. But yeah, for a quick run like this, I didn't see a reason to bother with that. So anyway, minus 33 degrees Celsius, and I think already, like, at minus 33 degrees, I already took the top score, but obviously, you know, it was just like, you got to push further. And yeah, here you can really see the oscilloscope doing its job. Like, you can actually track well, I don't use it to track the frame rate. You have a frame rate readout in the freaking benchmark, but yeah, I really like the whole using the oscilloscope. It will show, like, frame drops and stuff. Like, if the card is dropping frames, you will see, like, you won't see the frame render cycle on the oscilloscope, because the frame, like, as a frame is rendered, the card goes, you know, it pulls a little, like, I don't know what the freaking order of things is, but it goes through a load cycle where it pulls a lot of power, less power, a lot of power, less power, right? And that's what creates that sort of noise pattern. And so if it drops a frame, you don't get that noise pattern. You just get a gap in the noise. Where the frame wasn't rendered. And so it can be useful for, like, catching instability before it even becomes really obvious. Because if you're running, like, for TimeSpy, that's not really an issue, but there's other benchmarks that I've run where you might be running hundreds of frames per second. And, you know, if 1 or 2 frames goes missing, you're not really going to notice, but it will show up on the oscilloscope potentially. So, yeah, not that that was a real benefit here, but it is something kind of neat. It's just like, if you're pushing the limits of stability with the oscilloscope, you can actually see it. You can see some of the instability before it even necessarily shows up on screen, though it depends on what kind of instability you're having. Like, like, a lot of cards don't drop frames, but there are some cards that do, and the scope is really good at catching those. Anyway, another picture, this time at minus 60, and I pulled it all the way down to, I think, minus 82 was the lowest I had the card. And yeah, so this is the final run of the session, and I think we have a nice, actually, do we not have a nice picture of the card totally? Oh, I guess that might be the next, wait, what? Oh, what? No. That's not it. The hell? Why is it skipping that picture? Yeah, okay, so freaking program is being stupid and skipping the picture I wanted to show. This picture. I mean, this is the one that's on hardware bot, but yeah. So here you have sort of the card at the end of... Actually, this is not the... I think this is the before last run or somewhere like that. It's not... Like, we're not at minus 80. There was... Like, I literally did one run at minus 80 and then gave up. Yeah, so here you can see that just the LN2 pot just completely frosted over. And that's basically a snow layer on there. Like it's not solid, like that's not solid at all. And the real issue with this is if I needed to, like if the card had a cold bug or any weird cold behavior, this right here, because I use a hairdryer for reheating my LN2 pots. Yeah, if you hit this with a hairdryer, it sprays snow everywhere, which is just like not great. Luckily, the 3060 Ti is actually really well behaved. Like, compared to the 6900 XT, this was so easy. No cold boot bugs, no cold bugs. The memory actually would clock up as the temperature came down because, again, the memory was very upset when I was pre-testing that it was too hot. But I suspect the SK Hynix memory chips might actually scale to sub-zero temperatures. So, you know, if you committed to like a full-blown, like, as cold as possible run with one of these, you might find that you might be able to run like absolutely insane memory clocks. And I think the GDDR5X from Micron did the same thing where it's like on air cooling you could hit pretty, you know, some kind of memory clock, and then if you were at full pot on like a 1080 Ti, you could hit even higher memory clocks. And I suspect with the 3060 Ti on at least SK Hynix chips, that's probably also a thing. I can't confirm it because I wasn't really, like, I really wasn't messing with the memory clock at all, basically. Because messing with the memory clock causes, like, the driver to lock up, whereas clocking the core too far tends to be recoverable. But yeah, the card's super well behaved. So it kind of makes me sad that, you know, I only have one of them, and I didn't, like, because number one priority for the session was don't kill the card. All right, like, the whole get a good score or get good scores was secondary. My priority was do not kill the card. I have one. I ordered the 6900 XT decided to commit suicide, but I'm not about to murder this thing just because I didn't insulate it properly. And yeah, and this is so well behaved. Like, no weirdness. The 6900 XT, on the other hand, you take it sub-zero and it's constantly complaining. The memory controller goes to hell. Like, you can't freaking... It won't even render the desktop properly at low temperatures, the 6900 XT. I think it's due to some of the power saving stuff AMD has, but basically rendering a freaking window is very difficult for a 6900 XT at like minus 60 degrees. This thing at minus 80 runs basically the same as it runs at plus 20 or 50. Actually, it runs better. It just runs better as it gets colder. And what really impressed me was because I have I don't have like a shunt, like I don't have a power limit removal mod on this. I have a power limit, like I have shunt modded the card, but that's not a power limit removal. You just skew the power reading. What really surprised me is when I've been messing around with the card on air cooling, the VCore mod would actually very easily just hit the power limit of the card. Like, I had this card pulling over 300 watts of power on air cooling. So on the liquid nitrogen, I don't think actually. So I didn't remember to take a screenshot of this, and that would have been really cool of me if I had. But again, the priority wasn't like make pretty screenshots. It was don't kill the card, get some scores, you know, done. That was it. That was the only thing I wanted to do. But I think at one point I did check the GPU-Z power readout, and the thing is not for a full benchmark run because like having monitoring software in the background of your benchmarks lowers the score. Like, it's bad enough that you need to run 3DMark's freaking system info, which incidentally, turning off system info boosts your score. So if you're like pre-testing for 3DMark and you pre-test without system info and then you go for a full run with system info, that's a bad idea because your pre-testing is going to be giving you like results that are higher than they should be. But anyway, I think I saw the card reporting around 160 watts in GPU-Z with I ran it all the way up to like 1.13 volts, according to the oscilloscope. So yeah, that should be pretty accurate. Like, it's behind the core, it's on the coax. That should be spot on. So 1.13 volts, and at 1.13 volts at ambient, way over 300 watts. Like, huge amounts of power draw. Card gets hot. Like, yeah. But on liquid nitrogen at minus 180, or sort of minus 70 degrees range, the thing is we need to multiply that by 1.66, because GPUZ reading out 160 watts on a card with a 3 milliohm shunt resistor is actually, well, not 160 watts. So yeah, it never exceeded 300 watts on LN2, even with voltages that at ambient would have been pulling in excess of 300 watts quite easily. So yeah, these cards love the the card just freaking loves liquid nitrogen. There probably was plenty of headroom left. Like, the fact that it was pulling so little power means that I could have, like, I was worried about the 7-phase VRM, but it would have probably been fine, up to around like 1.2 volts maybe. Yeah, like 1.2 volts at minus 80 would have probably been totally fine for the VRM. Especially with the heatsink that I have on it, which in this configuration is actually pulling like cold air from the liquid, like from the nitrogen straight into the heatsink. So, yeah, like, really fun card to run. Like, really makes me wish I had a second one that I could just use as a like, that I wouldn't have to be worried about like killing it. And I could fully commit to going all out. Or if I just had a card that had a better PCB so that I didn't have to run it naked, basically. If I was running it with full plasti dip, I would have been willing to do, a longer session. But the thing is, without any kind of waterproofing on the card, you get water buildup in the VRM area, and that's how you lose power. Like, that's one of the quickest ways to have power stages fail, is because you have 12 volts, hanging, like, the entire VRM area, you just have a lot of 12 volt pins hanging around, and they're not necessarily designed, like, the designers of the power stages aren't like, how is this power stage going to react to, say, a water droplet bridging some of the pins? That's not how they're designed. So you really, really don't want to be running the card, like, an uninsulated card with like condensation buildup in the VRM area, which I didn't have any. Because again, the session was really short, and I was really doing my best to keep an eye on the state of the PCB, and that there wasn't like water buildup anywhere, and that there wasn't, the cold wasn't spreading too far through the board. Anyway, so yeah, so it's like really fun card to run. I definitely didn't max it out. Again, priority number one was don't kill card. Getting good scores was secondary. I actually wanted to also run Fire Strike, but I never got around to it. Right. Yeah. So I did want to do a Fire Strike run on the 3060 Ti, but didn't get around to that because when I went to try run Fire Strike, what ended up happening is I didn't have a CPU profile for Fire Strike, and honestly, I probably wouldn't have needed it. Right, like, even a badly set up 5950X will spit out easily 40,000 points in Fire Strike, but yeah, like, I was having issues just getting the benchmark to run, and after like 2 resets, I was like, okay, you know what? I'm done. Because the thing is, anytime the card isn't running a benchmark, that is, like, I think the GDDR6 on the card really helps with minimizing the cold spread, because the memory gets pretty warm, and it's not really directly cooled by anything. Yeah, so my concern was like, look, if I leave this idle for too long, it's just gonna freeze through to the memory chips, or maybe a bit past the memory chips, and then that's all going to turn back into water as soon as it goes under load, and I don't have any waterproofing. So, yeah, didn't really want to risk it. So when Fire Strike didn't immediately start working, I was just like, okay, I'm done, because I was having issues with system info. I wasn't having an issue with the physics test. I literally couldn't get into the benchmark. So I was like, get to desktop, try to open Fire Strike, crash on like when system info does the thing that it does. Yeah, it would crash because system info actually puts a higher load on the CPU than the freaking physics test does. So you can actually run physics at higher clocks than you can start the benchmark at, which is like great. Now that's not true for Time Spy, but it is really very true for Firestrike. I'm not sure about Time Spy, but Time Spy is heavier. As long as you disable the SMT. If you have SMT turned on, then Time Spy actually doesn't work properly, which if you're wondering about how you get like over 19,000 points on a 5950X, Infinity Fabric clock and yeah, disable your SMT because Time Spy only uses 16 threads. Firestrike uses 32 threads, but Time Spy doesn't. So anyway, where was I going with this? Yeah, so that was kind of the, like, I only got this score out of the card. That was the end of the session. I didn't get around to running anything else. I wish I did. I'm pretty sure that, you know, if somebody committed to running a 3060 Ti on liquid nitrogen properly, 15,000 points is easy. Like, straight up easy. Like, if you have a 5950X or a 7980XE or 9980XE or like an X299 CPU to, you know, carry the CPU score for Time Spy, like, 15,000 points, easy. Super easy. Honestly, even 16,000 points would probably be doable for the overall score. But, yeah, and I think 15,000 GPU score is definitely doable as well. Yeah, that wasn't, you know, like, my priority was just to keep the card alive, and maxing it out was sort of secondary. The annoying thing is definitely the mounting hardware. Anyway, here's the condensation buildup right at the end of the session. So this is, and actually I don't think I was super quick with taking the photo. So yeah, this is from the end of the session, and you can see that basically, and this is why I think really the memory chips were doing a really good job of making sure the card doesn't freeze through properly, because you can see how the memory chips, those are dry, right? And then you have like the ice buildup sort of, especially around the core, because you can kind of tell where the power plane is. As far like the power plane on these cards basically does a sort of like around there. And then I think it shoots off to this side. Well, actually there's the 1.8 volts rail. There's a rail that runs through there. There's like a little power strip that runs through there. So you can sort of see the ice spreading through that. You can kind of see the edges of, I think that's the ground plane right there, maybe. Or actually, that might not be. That might just be. Well, no, that's really. So on some boards, you can actually see when you freeze them through. You can see the power planes just based on how the frost starts forming. But anyway, so yeah, this is after I pull. Like, this is the first card turned off. Take the towels off, and this is what it looked like. So yeah, that did a decent job because I left the card sitting on my desk, powered off, you know, disconnected from any power, so wasn't concerned about the condensation at that point. Like, I literally wash cards with water, so, you know, water is not bad for electronics unless there's power, right? Yeah, so this is what happens if you just sort of leave a card like this sitting around. Right, like this literally just, like, I sat it on my desk. I didn't even add any more LN2 to it. Like, I just sat it on a table I have and left it like this, and this is what ended up forming pretty quickly. And you can see, like, here we have liquid water, which is really bad, and it goes all the way down to the PCIe slot. And like, if you don't properly prep your hardware, this is what it ends up like. This is what you need to prep for if you're going to run longer sessions. Is just like everything is going to turn into ice pretty quickly. Yeah, it gives us some pretty nice definition on like the memory power plane in here, right around there, and here. That's kind of neat, but yeah. Now, the funny thing about this card is it actually doesn't have like a V-core power plane running through this area at all. But yeah, so that's sort of what the insulation sort of did its job. It wasn't perfect, but I didn't expect it to be. And the card survived, and I got the like score that I wanted. All right, 2400. That's obviously peak clock. Let's actually check what 3D Mark was reporting as average clock, because I have no idea. 2300, so not bad. Memory clock was 2058. This could have definitely gone higher by the time I had the card at minus 80, but I really didn't feel like, you know, pushing my luck with fiddling with the card too much. Apparently better than 98% of all results. And yeah, also here's the LN2 pot from the end of the session. The front of the card was actually dry, but I don't have a picture of that. Because, like, basically, like, I only thought of taking the picture of the thermal paste application after I sort of started disassembling the thing. So you can see how this is actually now covered in, like, water droplets, because I warmed up the LN2 pot just to get the card out, like, off of it. And then I let it to freeze, like, because the thing is, well, no, I heated up the card in the process that melted the frost that formed on the LN2 pod in this area. But you can kind of see how where the shop towel was, there was basically no condensation because there wasn't any airflow in that area. And so the front of the card was dry. It's just the back of it that was, well, the front of the card where the shop towel was, that was dry. So, like, the memory chips were dry, the immediate area around the core was dry. And yeah, so, you know, like, that there. But that's kind of, like, that's very normal. And yeah, you can really see how the card was at a bit of an angle. The thermal paste application looks good to me. Nice even spread right there. Also, this isn't fresh Cryonaut. It's just Cryonaut that I had, like I scraped the... Actually, was it? Actually, no, I think this was fresh. Maybe? I'm not sure now. I'm not sure. Like, the thing is, Der Bauer sent me, like, so much Cryonaut Extreme that I actually don't know how much I have. Like, I think he sent me 4 tubs, 4 70-gram tubs. Yeah, like, the thing is, I can't judge the paste from this session. I've done other sessions with, like, soldered CPUs, and there it works great, but that's soldered CPUs. If you're having thermal paste problems on, like, a Ryzen chip, or a 10900K or 11900K, your thermal paste has to be terrible. And there are thermal pastes that even on, like, a 10900K, they will not work. Because I've tested some pastes which at, like, minus 60 degrees, they just did, like, stop doing their job completely. But as long as you use a halfway decent LN2 paste, like, you should be able to go down to full pot on a soldered CPU without issues. And so I wasn't really, like, and in the sort of, like, down to around minus 100, you shouldn't have, like, problems with thermal paste on, well, anything in my experience. Well, X99 is well, HEDT Intel will over time wear the paste out. But you can restore it by just warming up to, like, minus 10 degrees Celsius, and then it starts working again. And minus 80 on a card like this with, you know, minimal amounts of heat load, like, yeah, that's not going to be a thermal paste benchmark. So, great thermal performance, but in terms of stability, I've really not pushed the paste here. But yeah, thermal transfer-wise, great paste. Definitely does a really good job. Stability-wise, I haven't yet tried to run it at full pot on a GPU or, like, a delidded CPU. Yeah, so I don't, because that's where you get the major problems. Is very low temperatures on very high heat densities, and that's where you sort of get your thermal paste getting absolutely hammered. Anyway, yeah, so there. Took the 3060 Ti on LN2. Really fun card to run. I kind of wish there was more competition in the 3060 Ti rankings. I'm actually kind of wondering what other 3000 series cards are popular. Like, I'm assuming the 3090 is, like, disproportionately overrepresented on HardwareBot because HardwareBot users are more than willing to buy incredibly expensive GPUs. Yup. Like, you can tell that there's a lot of competition for a GPU just based on how many points you get for being first, and of course Bisso is. So if the card gets like anything that gets over like 30 points is pretty damn popular. Anything getting 50 points, very popular. So if we go, yeah, it's got to be like over 100 submissions. Yeah, there's a lot of 3090 posts. Which, yeah, and then like the more reasonably priced, don't break the bank cards, you're kind of screwed. Actually 6900 XTs are also unpopular for that matter, I think. Which doesn't surprise me. Like, running a 6900 XT on LN2 is just, I hate like, it's the kind of thing you do to yourself when you hate yourself. It's just like, yes, I want to have the worst possible LN2 overclocking experience ever. Get yourself a 6900 XT, try run that on liquid nitrogen. Like, it's actually worse than Vega. Vega is fine until you go below minus 75 degrees Celsius. Like, it renders the desktop. You know, it does all your basic freaking GPU things. And then you have the 6900 XT, which just barely freaking functions at low temperatures. So yeah, 39 points for that. Because the thing is, I can't afford a 3090. It's really that simple. It's just like, why didn't you run a 3090? Because they're too damn expensive. And also, I wouldn't put a 3090 in my daily. Like, that's the kind of card that I would run until it blows up. Or think about running till it blows up. Think about running until it blows up. 3070s are a lot more popular. Guess I could have done that. They're not really any different. Like, 3070s are basically big 3060 Ti's. So... Actually, they're not even basically literally. They're literally big 3060 Ti's, right? Like, you just get 20% more cores, and it uses the same type of memory. You still use GDDR6. I wonder if the GDDR6 from Samsung is like really badly behaved on liquid nitrogen. It shouldn't be, because I don't remember hearing anyone like with RTX 2080 Ti's complaining about the memory getting annoyed, like memory complaining about the cold. Yeah, like some of the GDDR5 Samsung chips, and even SK Hynix, actually no, SK Hynix was a different issue, but GDDR5 Samsung memory hates being cold. So yeah, anyway, so 3060 Ti, I currently have the TimeSpy top score. This would be very easy to beat if anybody actually committed to running a 3060 Ti on LN2 properly. Honestly, you don't even need to make your card look like this. You mainly just need a core voltage mod. I don't even think you necessarily need to bother with modding the memory voltage. Maybe at some high core clocks, the memory starts being a serious bottleneck, but I think initially it's just going to be... Like, the thing is, the 3070 has, like, the same size memory controller as a 3060 Ti. And the 3070 still has plenty of headroom in terms of core performance, so... I think the memory controller on a 3060 Ti is actually probably a little bit oversized for how fast the actual core is. So 3060 Ti is probably, like, I don't think they're too limited by the memory clock. So you probably don't need to bother with a memory voltage mod at all. But core voltage, you definitely need that because, yeah, I had the card cranked all the way up to 1.13. At stock, the card normally sits at around 1.06. And I'm not talking about software voltage readings, I'm talking about the measurement behind the GPU core. It normally sits at around 1.06, regardless of what it's telling you in software. So, yeah. Anyway... Well, actually, it doesn't normally sit at 1.06 if you don't have, like, the power limit removed and aren't sub-zero. At ambient, it'll actually go pretty low voltage, but yeah, you do need a volt mod if you want to push the clocks up. And finally, the card is now in my daily system, and for daily, it sort of produces 13,175 points, and that's with the 3950X that I have. So, yeah. Not that much of a gap in the score. I really didn't push it that hard on the liquid nitrogen. Like, it was supposed to be a quick session. I feel kind of bad, like, taking first place with a configuration like this, where, like, I'm not apologizing for the 5950X, because Extreme Funky was on a 7980XE. Actually, 9980XE. So, you know, if he dry iced the CPU... that chip can easily spit out over 20k CPU score. He could have literally had a bigger CPU score than I have. So the 5950X I feel is completely justified, but yeah, I feel bad for not pushing the card further. Yeah, because it definitely, like, there's room. There's so much room left in it, but also, like, yeah, anyway, this video turned out way longer than I was initially planning for it to be. But yeah, we've covered everything I wanted to cover. Probably not the most efficient manner I could have, but nothing I ever do is. So, yeah, I mean, like, the overclock that I currently have on my 3060 Ti is definitely not prioritizing efficiency, right? Like, um, yeah. But anyway, that's it for the video. So, yeah, I guess thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below, which is how I was able to afford this 3060 Ti. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you'd check the links out to them. And yeah, that's it for the video. Thank you for watching, and goodbye.